Now, how about going from a radical to power form? Remember, a square root is a half power. So since we have a square root of x to the 7th in this first example, that's x to the 7 over 2. The numerator is the power on the radicand inside the radical, so that power is 7 on the radicand. And the 2 is the number that's default as number here. If there is a number here, like 3x to the 5th, it's x to the 5 thirds. The denominator and the index have to match up, and this power and this have to match up. Same thing in number 2. You put the -2 in front, no matter what number it is, and you do x to the 5/8 power. This 5 matches with this 5. This 8 matches with our index. Same thing here. The 5/9 goes in front. You have x to the 10 over 4. But sometimes, like it's 10 over 4, you actually got to simplify the fraction to 5/9 x to the 5 over 2. Let's do one more example in radical to power form to really emphasize it, and then we'll do the reverse. So let's say you had nested radicals. What do you mean by nested radicals? You had the square root of the 5th root of x squared. That's the same thing as x squared to the 1/3 to the 1/2, and then you multiply. So 2 times 1/3 is 2/3. 2/3 times 1/2 is 2 to the 1/6. So that's x to the 1 to the 2/6 power, or x to the 1/3 power. And that's how you do it if you have a nested square root inside a square root, or a radical inside a radical. And to really emphasize, if we had 2/3 parentheses the 7th root of x to the 5, that'll be 2/3 x to the 5/7. You just rearrange this part using the number inside as your numerator, and the number in the index as your denominator, and the coefficient comes along. Let's work on going backwards. So what I mean by going backwards is what happens if you start in power form and you want to go to a radical. So let's do a few examples. So if we had 15 root x, that would be 15 x to the 1/2. That was what we did before. Now if we did reverse, if we had 3 x to the 1/3, that would be 3 cubed root of x. And I keep on going. Let's say I had 23 x to the 4/3. That would be the cubed root of x to the 4 with a 23 in front. One more example before I erase. 14 negative x to the 5/8. That would be -14 8th root of x to the 5. You notice these numbers are always outside. We're not dealing with numbers in parentheses, numbers in any other location as such. Okay? Let's do one example where we combine the previous video and this video, and one example where there's parentheses. So what do I mean by combining the previous video? We're working with negative exponents. So if we had 3 over the 5th root of x squared, that'll be 3x to the -2 over 5. Or let's say I had 4x to the -3/7. That'll be 4 over the 7th root of x to the 3rd power. That's combining both the rules. Let's wrap up with a parentheses example and show how parentheses change things. and that's it. So if we had parentheses in either example, let's say we had 2x to the third power raised to the 1/5, this would be the fifth root of 2x to the third. But if we didn't have parentheses, we just said 2x to the third, that raised to 1/5. In this case, the 2's outside, and the x to the third is inside. So with parentheses, it changes the answer, makes a major difference, and parentheses are extremely important in your question. Okay, I hope that was useful, hope that was helpful, and there'll be more videos coming out on how to do operations with fractions and how to graph exponential functions and power functions. This is Mr. Spy. Subscribe to my channel. Subscribe for notifications. There are going to be daily videos almost during Mondays through Thursdays. This is Mr. Spy, signing off.